Hello and welcome to the Providence College Podcast. I'm your host, Liz Kay, and I'm joined by producer Chris Judge of the class of 2005. Here at the Providence College Podcast, we bring you interesting stories from the Fryer family. This week, we're talking with Dr. Jay Pike, an assistant professor of chemistry who's taught at PC since 2001, and Alex Ventouris, a rising senior and biology major. Dr. Pike has been brewing beer since he was a doctoral student at the University of Michigan. Now he and his research students, such as Alex, are studying how to decrease some of the organic compounds that create off flavors in beer. He also teaches a course titled The Scientific Chef. Dr. Pike and Alex, thanks for joining us.
Thank you very much.
Thanks for having us.
Thanks for having us.
So, Dr. Pike, could you tell us how you got started with home brewing in the first place?
Oh gosh, it was my second year of graduate school. One of my roommate at the time, he and I were actually really interested in possibly making our own beer. And so we bought a little kit. We used a malt extract. I remember this liquid, like it almost looked like caramel syrup. And it took off from there. We brewed for, 3 years. And we made all sorts of beers. We never really got into all grain recipes, which is what we do now. But we stuck with that malt extract. And at the time, this was 96, 97, there were no recipes online. You basically went to a little store. We had a little store there that carried all the supplies. And we said, I'm interested in brewing a pale ale. What would you suggest? That type of thing. So that basically carried on for 3 years, even into when I met my wife. And then we started having children, and it faded away. Just because, you run out of time. So I didn't get back until about a year and a half ago or so. And at that time, I told my wife, I've been doing this all malt extract for a long time. And I said, I'm really curious to see what it would be like to do all grain. And so I bought a nice little rig, and it was a lot easier than I thought, and it was a lot of fun. So, and it also brought, it kind of tied into the course that I'm teaching, The Scientific Chef. So I've been teaching The Scientific Chef, I guess logistically for only a year, but before it was called The Scientific Chef, it had a different name. So the course is essentially the same. And in that class, as part of that class, I actually described to the students the chemistry and biochemistry of beer brewing. And so it really brought that, to fruition. I was like, oh, this is really cool, So, yeah.
Why were you curious in the first place to start? Were you trying to save money on a grad student budget?
Not really. Yes, you do save money, but it was more for the experience, seeing if I could actually brew some good beer that, I just did myself. As a trained scientist, we spend all of our years preparing and measuring and it gets into our head. And so oftentimes we go, here's a process. Can I do it just as well as somebody else? And so that's basically where it started. That's why I became interested in the all grain brewing, because, it's a little bit more complex. And so I was like, wow, I think I could do this. And sure enough, we're making some pretty good beer,
So could you tell us about the research you're working on now?
Sure. So in January of this year, let me rewind just a little bit. In November of the fall of 18, Paul Check, our chair, had come to me and he said, I know that you're thinking about starting a research project in brewing science. And I'm going on sabbatical in the spring of 2020, And at the time, I was thinking, well, I'm going to start it up then. And so what happened was he's like, well, you think you could start it maybe a little sooner? So I asked a few students around. I asked a number of students, actually. And before I knew it, I had 5 students that were interested in brewing beer with me. And so in January of this year, we basically got started. And so I have 2 projects. One looks at yeast and the flavors that yeast are producing. So I'm very interested in how flavors are produced and the chemicals that actually produce those flavors. And so that's basically Alex's project for this spring term, was looking at 2 yeast strains. Although we never got to that point, we basically had to do standardizations and look at molecules and try to analyze them and all sorts of things. But my second project has actually to do with an off flavor in beer called diacetyl. And diacetyl is produced as a byproduct of fermentation. So anytime you have fermentation, this compound can be formed. And what we're really interested in is seeing if we can kind of control the production of diacetyl. So if we can minimize the production of diacetyl, because essentially what happens is if you can do so, breweries will be really happy, because most of fermentation is accomplished in a few days. And then what happens is the yeast, you have to allow the yeast to kind of spend some time in cleaning up a lot of these byproducts. And that can take anywhere from a week to 3 to 4 weeks. So if we could find a way to minimize those off layers, then you're basically cutting brewing time, fermentation time down considerably. And I'm sure the production of beer would increase if we need more of that. I'm not sure. Anyway.
But definitely speeding up the production time would be a benefit. I think a lot of brewers would be interested.
Certainly.
So, Alex, what drew you to this research project? Why did you want to get involved?
So I actually took Organic Chemistry 1 in the fall of 2018 with Dr. Pike. Mm-hmm. And he approached me towards the end of the semester and asked me if I was interested in doing research with him. At the time, I was working in a bio laboratory with Dr. Waters here, an entomology laboratory working with ants. And I really enjoy chemistry. I always have. And if I could do it all over again, I'd probably choose to be a chem major.
It's never too late.
So I was really interested in working with him. And when I found out that it had to do with beer, I was even more intrigued. Something I've always wanted to try doing, brewing beer. And so, I got started in January. We started brewing in January. I remember our first brew day. Dr. Pike texted all 5 of us with this little emoji in our group text. It's brew day. It was funny.
We call ourselves the Brew Crew, PC Brew Crew.
Yeah. But it's been a while now, since January, that we've been brewing, and it's becoming a great hobby of mine, and I hope to start doing it on my own, maybe post-grad.
Cool. So what do you feel like you've gained from the experience so far?
Well, brewing is a very a tangible thing. It's right in front of you. You're hands-on. It's not a microscience. It's more of a macro science that you can see. And what I've gained from it is just I've learned how to deal with these long days, like waking up early and starting to brewing all day long, and then afterwards doing the distillations that I have to do. And it's been a grind, but it's been a good grind. I'm enjoying it a lot.
And have you gotten some faculty, some support for your research in terms of a grant from college?
Yeah, actually, Dr. Pike applied for a CAFR grant.
Right.
The chemicals, I'm not sure what the CAFR stands for, but...
What does CAFR stand for?
It's the Committee to Aid Faculty
That's right.
Research.
Yeah, that's it.
Committee to Aid Faculty Research. Yeah. They actually, a lot of the students, all of the students applied for funding through the school, and unfortunately weren't successful at it. But I had applied for a CAFR. It had been several years since I have received a CAFR, and fortunately, I was able to convince the committee that this was a worthwhile project, and so I had asked Alex. Well, he had approached me mid-semester, wondering if there was any opportunities to do research in the summertime, and I said, well, I'm applying for a CAFR, so hopefully, and I was fortunate enough to get it. So it's paying obviously for Alex's summer stipend for him to work, and it's also paying for a couple of supplies. Where we just purchased a couple of new fermenters that are really nice, and obviously when you brew beer, there are a lot of ingredients, and so you're constantly ordering ingredients, and that takes money. So.
But ordering from a different catalog than you normally would.
Oh yes,
No.
Yeah. It's kind of strange because the chemistry department is set up to order chemicals from chemical companies, and so I'm very a fish out of water, essentially, because all of the stuff that we order is from companies that are not chemical companies, and essentially what happens is I tend to order it myself and then get reimbursed. That's the easiest way to do it.
Just got to get it done. So could we talk a little bit about the scientific chef and like the topics you've covered in the course?
Sure. I've been teaching. The Scientific Chef essentially is a course for, it was designed for non-science majors. When I started teaching, there was a course called Contemporary Chemistry, which still exists, and some of my colleagues still teach it. And it's essentially, the basics of chemistry. And I thought, wouldn't it be interesting to be able to take a topic that I'm passionate about and teach students about the chemistry of it? So I approached the chair at the time, and essentially I was allowed to create a course on the chemistry of food. Interestingly enough, there's a lot of my colleagues are also very interested in food chemistry. And so essentially what I do is I spend a couple of weeks talking about very basic chemistry so that the students have an idea about, for example, what a molecular structure looks like. How do you draw a molecular structure? How do you draw organic compounds? I'm sure a lot of people in the audience have seen pictures of organic molecules, and they're basically these bonds, these lines that everybody sees in these shapes, and they really don't know what it means. And so I go in and I spend a couple of weeks talking about what they mean, and then we start exploring the chemistry of. So, for example, the first topic that we talk about is milk. And we talk about basically the composition of milk and how it can deliver proteins, fats, it can deliver sugars, it can deliver vitamins in a specific way. We talk about micelles, and so they really get into the detail of milk, and then from there we talk about cheese. And so they actually learn how to make mozzarella cheese. We're making mozzarella cheese in class. We spend 75 minutes making mozzarella, and then the next time that we meet, we actually taste mozzarella. So it wouldn't be a science class if we didn't do a little experimentation. So what we do is I bring in milk of various types. So I bring in whole milk, 2% milk, and fat-free milk. And we make mozzarella with those three. And then we compare the flavor and the texture of the cheese that's produced from each one of them. And of course, they then see firsthand how important fat is to cheese production, which, I mean, when you see mozzarella cheese produced from non-fat milk, it's basically rubber. And then I make them eat it. And it's disgusting.
Because if you've taken the fat out of the structure,
That's
it's
right.
all just...
It's exactly what it is, right? And so then we talk about vegetables. We talk about the structure of plants, right? And we talk about a little bit about the nutrients that you get out of vegetables, carbohydrates, right? Mainly, we talk about how plants store glucose and convert it to starches, and then we talk about meat. We talk about the structure of meat and whatnot, and then we get into bread, and then lastly we talk about beer, right? And so by the time that they get to beer, they've spent a lot of time. We spent a lot of time talking about the structure of glucose. They know how to draw the structure of glucose. Coming out of my class, right? Coming in, they have absolutely no idea, and going out, they know in detail about the structure, which is kind of cool, right? They're always hesitant at first. They're like, oh, I don't know if I'm going to be able to do this. But at the end, it's like, wow, I really know a lot about it. And not only that, I know that carbohydrates are essentially long chains of glucose molecules, and that there are enzymes that plants produce to basically cleave up those starches, right? So that's really important when it comes to beer, because when you start in in producing beer, you start from barley, malted barley. So they even know that what is malt, right? I mean, we hear that term often, but we oftentimes don't know what it really means. And essentially what that means is that you take a grain, and it could be barley, it could be wheat, it could be oats, it could be a number of grains. In brewing, we typically use barley. That's kind of the staple. And you steep it in water at roughly 60, 65 degrees, because you're mimicking the springtime. And so what happens in the springtime? Well, seeds start to germinate. And it's that germination process that's really important in terms of beer, because during germination process, you start to produce a lot of enzymes. And what enzymes do you produce? You produce enzymes that break down starches, right? And then essentially, so you start that germination process, and then you stop it. And that's what called malt is, malted grain, right? You have begun germination, and then you've halted it, and you've dried that grain so that it can't actually proceed to germinate. So that when you then put it into boiling water, basically, or water at a specific temperature, all those enzymes are already there, and then they're ready to basically start consuming the starch and producing sugar. So there's kind of an old saying that brewers do not make beer. Brewers make flavored sugar water, and it's the yeast that makes the beer, right? The fermentation is what makes the beer. So that whole process of, well, how do you do that, and what temperatures do you run, and so oftentimes the next step in brewing is what we call the mash. And when you mash, you actually bring water up to a particular temperature. And that temperature depends on the types of enzymes that you want active, right? So the main enzymes are called amylase enzymes, and amylase basically breaks down amylose, which is starch, into glucose, and essentially maltose. I mean, a lot of maltose too. So yeah.
Well, you actually returned to the classroom yourself pretty recently as part of your training as a craft brewer. Can you tell us about that experience?
I did. Yeah, I owe that to Facebook, oddly enough, which I'm rarely on, unless my wife yells at me that something's going on in my family and I should be aware of it. But it happened that I was on Facebook and I saw that Johnson & Wales was offering a certification program in professional craft brewing. So I approached Paul Check, my chair, and I said, hey, I'm really interested in this as a professional development course, and that I'd love to be able to actually develop a course in the chemistry of brewing, right? And so he was like, yeah, sure, give it a whirl. So in the fall of last year, fall of 2018, I started taking classes, and that was quite an experience. It was Thursday nights, and the first class was called The Art of Brewing. And basically, it trains you to taste beer. So most of us, when we drink beer, an alcoholic beverage, we're not tasting it, we're consuming it, right? And so this course was really designed to show you, number one, the different types of beer. There's many types of beer, right? So most of the time we're used to lagers in terms of Budweiser, Miller Lite, whatnot. So we're kind of used to lagers, and then of course IPAs are the big craze nowadays. And for the most part, that's what many Americans kind of think about. And that's pretty much what I thought about. I kind of had some ideas about Belgians, right? And of course, when I was brewing, I explored other options as well, but those were the staples. And so it was really kind of fun to taste a really nice German lager. And it was like, wow, this is like drinking liquid bread, right? Very different than a hoppy beer that you're used to. So that was that course. And then we got into advanced brewing, which was really fun for me because there was chemistry involved and nobody in my class knew how to do it except for me. So I was kind of the go-to guy, talking about, obviously water is very important when you brew. The mineral content in water is important, and it can actually change with the style of beer. So you add different minerals to your water in order to mimic the water profiles typically of cities that are famous for brewing, right? So German cities, Belgian cities, English cities all have a different water profile, and you can basically add salts to it to mimic any one of those water profiles. So in order to do that, you have to know something about molar mass of salts and mole ratios, and so that was a lot of fun for me. Just seeing the panic on a lot of my classmates going, oh, we don't know how to do this. Jay, you can do this. Help us out. And then the third class was actually the business of alcohol product development and distribution. That was an eye-opener for me. I had never really taken a business class before. And so it really introduced the complexity of opening up a brewery. Most of my classmates are interested in opening up a brewery or working for a brewery. And so, seeing that brewing beer is a minor component of owning a brewery. It's one thing for somebody to tell you that. It's another thing to see it for yourself. So that was pretty cool. And then I'm just finishing up the capstone course for that. So That ends in the middle of August, and essentially it's brewing beer. So last Saturday, I went into Johnson & Wales, and we brewed a beer for Homebrew Con, which is a convention for homebrewers, a national convention for homebrewers, and it happens to be in Providence, Rhode Island this year. So we were really excited to be able to get a beer in, and we were kind of under timeline crunch, and so this Sunday we're actually kegging that beer so that it's ready for HomebrewCon, which is the 27th and 8th, I believe, of June. So it's coming up in a week or so. Yeah, a week. Gosh, it's crazy.
Well, with all your experience as a scientist and a home brewer, I wondered if you could share some tips for people who are enjoying beer at home. I mean, you're doing research on the off flavors in beer. Is there anything that we can do to prevent those from forming in the beers that we're drinking?
So diacetyl, you can't really do much about. That's the responsibility of the brewer to make sure that it's not in there, to make sure that fermentation has happened long enough so that when they bottle it or can it or put it in a keg, it's not present. So one of the big things is skunked beer, right? How do you avoid skunked beer? Skunked beer actually comes from hops. So what happens is when you put hops into beer, there are compounds in there that isomerize. They're called iso-alpha acids. And when you shine blue light on them, right? So visible light, what happens is there's enough energy there for them to react with some proteins in the beer, namely proteins that have sulfur in them. And they produce a compound, I think it's called 3-methyl-2-butene-thiol, 1-thiol. That is basically what skunks produce in their glands. It's the same compound. And so when you say, ooh, it smells skunky, yeah, it's smelling like a skunk. And really the only thing that you can do about it is not leave your beer out in the light. So this is why a lot of beers come in brown bottles, right, or cans. Can is the best way. If you're going to be out in the summertime and and you want to have a beer, get it in a can. A brown bottle will help, but there's a little bit of light that passes through it. The worst thing you can do is pour it in a bottle and sit it out, in the sun, because it takes, I'm not kidding you, 30 seconds for that reaction to occur. And pretty soon you're going to start to smell skunky. So this is also why a lot of European beers Americans think are skunky. Because they oftentimes will ship their bottles, they'll use clear bottles or green bottles, and those are the worst bottles for that skunky smell. So if you're buying a beer and it's in a clear bottle, it's going to be skunky. I mean, there's really nothing to get around that. And it's interesting because a lot of people go, well, what if I heat it up and then cool it down and heat it up? Is that going to skunk it? Nope, that does not skunk beer. It reduces other flavors, so it does affect the flavor, but it doesn't skunk your beer. And
so when we talk about temperature, though, what's probably the best temperature? I mean, I think people talk about enjoying a cold beer, but is that...
Yeah, so if you think about... again, it comes back to that taste and smell, right? And when you're enjoying any type of food and or beverage, right? You're really trying to enhance your senses of both aroma and flavor. And in order to do that, you actually have to drink beer a little warmer than cold, right? So nowadays, I'm always skeptical when somebody says, "Oh, you got to drink it cold." The reason you have to drink it cold is usually because you're masking off flavors. So a good beer, you actually want to drink, 38 degrees Celsius, 35.
Not degrees Celsius, not degrees Celsius.
What's that?
38 degrees Celsius.
Oh, I'm sorry. 38 degrees.
You want it boiling?
Yeah.
You want it at human body?
Yeah, exactly. 38 degrees Fahrenheit, sorry. Yeah, that would be terrible, right?
A hot mug of boiling
So that's basically, where I set my temperature is I think I set my, I have a Keyser at home, which basically is a freezer that I have converted into a refrigerator that will hold kegs of beer. So my wife loves me. So I have 4 kegs in there, and I have taps. She's always going, well, what if the kids decide to, just dive into this? I'm like, well, if it happens, I won't know about it. She's like, well, can we put a lock or something? No, I'm not going to do that. But anyway, so I have mine set, I think, at 35 degrees Fahrenheit. So then when it comes out, it warms up a little bit, and that's really the best time, right? Because then you can really start to smell the malt flavor from the grains, and you can really smell the hops, right? If you're drinking something that has a lot of hops in it, right, citrusy and whatnot, and they come out a lot easier and a lot better at a little warmer temperature.
What about foam on beer? You talking about the head and
I love foam. Some people really don't like to have a head on a beer. Some people do. I actually think that it helps in getting some of those aromas out, right? To have a good head on your beer. That's actually, we work a lot in trying to design beers that when you pour them, the head on that beer is going to last for minutes, not just a few seconds, because it does do something to the aroma of beer, definitely, yeah.
Capture it and kind of, as the bubbles pop. And you can...
Exactly, yeah.
So, Dr. Pike, we can get beer in all different containers these days, glass bottles or cans. I'm curious, which is the preferred?
Well, in my opinion, cans are probably the best way. Number one, we talked about how you can get skunking to occur. So in a can, there is no light getting in, and therefore you can't skunk your beer that way. There used to be an argument, actually, for not having beer in aluminum cans, and the reason for that was because you could get this metallic taste to come out. That argument's actually gone away now because nowadays they line aluminum cans with a polymer, basically. There's chemistry again. And so it's the easiest way without producing any metallic flavors also to keep that beer fresh and as close to what the brewer imagined it to taste like. Yeah.
Because there'd be less oxygen in a can, right, than a bottle?
So, yeah, I would say that's kind of that would probably be up for debate, in terms of oxygen, because you do have to have a little bit of headspace in both can and bottle. So the way that home brewers bottle is a lot different than the way a professional brewer is going to bottle, right? Professional brewers, they actually carbonate their beer in tanks. So they're called bright tanks. Or nowadays, sometimes in the fermentation tank. So a new technology has allowed brewers to to do essentially everything from fermentation to clarification to carbonation in a tank that they call a unitank, right? It's a fermentation tank, but it also will clarify and it also carbonate and do all sorts of things. And then what they do is that they pump that beer into a bottle and or a can. Homebrewers don't have that. So what oftentimes they do is they add a little sugar to the bottle, and then they add their beer. So in that beer is still yeast. And so they rely on the yeast to consume the sugar that they put in, and then it carbonates that way. It's a natural carbonation. And it takes anywhere from 1 to 2 weeks, right, to do. So when you're bottling your own beer, you have to wait a couple of weeks if you're not kegging it. But there's always a little bit of oxygen in there. The idea, though, is that when yeast ferment the sugar, they produce carbon dioxide. And so that carbon dioxide forces the oxygen out of the solution.
Dr. Pike, Alex, thank you so much for joining us on the podcast.
Yeah.
It's been a
Thank
great
you so
conversation. Subscribe to the Providence College podcast in all the usual places, including iTunes, SoundCloud, Stitcher, and Google Play, as well as our newest platform, Spotify. If you like what you hear, please review and share with others. Thanks for listening, and go Friars.